This is one of a series of 6 general revision videos for Maths GCSE at foundation level. These are based on the revision mats provided by pixiemaths.co.uk in the link below. So this is the algebra version, and I'm just going to work through these in turn. So simplifying, y plus y plus y plus y, that is 4 lots of y. Not to be confused with y times y times y times y. If you've got the multiply sign, then that is a power 1. Y times y times y times y is y to the power of 4. But if it's just plus signs, that's nice and easy. You're just adding them together. You've got 4 of them. 3a plus 4a plus 2a. 3, 4, 5, 6, 7, 8, 9a. Here we need to look at the same letters collecting like terms. 5s and the sign in front of any other s's. So 5s plus 3s is 8s, 5t plus 5t plus 2t is 7t. In this one, 6f, and again looking at the sign in front, that is 6f minus 3f, so that is 3f, and then I've got a positive 5g and an extra 3 more g, so that is 8g. In this one, z's, I've got 4z minus another 2z, so that gives me 2z. And then I've got minus 3w minus another 3w, so altogether that is minus 6w. Anyone who finds those difficult, the plus and the minus, the main thing is to check the sign in front of it, but of course it might be that you struggle with negative numbers altogether, in which case you need to look at directed numbers and just practice work with directed numbers. That'll be in the number revision version of this. Then solving simple one-step equations. X plus 4 equals 11. I want to subtract 4 from both sides, leaving me with x equals 11 minus 4, which is 7. W minus 6 is 23. I need to do the inverse operation of minus 6 to both sides, so that is plus 6 to both sides. W equals 23 plus 6, which is 29. 5d equals 70, that's 5 times d equals 70. Inverse operation of multiplying by 5 is dividing by 5. So I divide both sides by 5, leaving me with d equals 70 divided by 5, which is 14. K over 4 equals 7. We normally see that written like this. K over 4 equals 7 as a fraction. In order to undo that division by 4, inverse operation of dividing by 4 is multiplying by 4. So I do that to both sides and get K equals 7 times 4, which is 28. 2 steps involved here. First step is to get the term involving x on its own. So the inverse operation to plus 6 is minus 6. Do that to both sides. That leaves me with 2x on this side. 12 minus 6 is 6. Now to get x on its own, inverse operation of multiplying by 2 is dividing by 2. That tells me that x equals 3. And with all of these, I should check my answer. If x is 3, 2 times 3 is 6, add another 6 is 12. That's correct. Expanding brackets. Just need to remember to multiply that number in front by both terms in the bracket, or however many terms there are. 3 times a is 3a, 3 times 4 is 12, with a plus sign in between. 5 times c is 5c, 5 times 6b is 5 times 6 is 30b, and it's positive. 4 times x is 4x, 4 times 3y is 12y, and it's negative. A times by a is a squared, not 2a, but a times a is a squared. A times 5 is 5a, and it's positive. X times by 4y, I can't simplify that other than putting them all together. 4xy, normally in alphabetical order. X times by 2x is 2x squared, with a minus sign in between. Followed through. On to the nth term of sequences. First thing in this is always to spot the pattern, what's going on between each term. So I'm adding 3 each time. These are arithmetic sequences or linear sequences, so they're always going up by the same amount each time. That plus 3 tells me that this is something to do with the 3 times table, which is 3n. I remember that n for these is always, n is 1 for the first term, then it's 2 for the second term, 3 for the third term, etc. So 3 times 1 is 3. How do I get from 3 to 5? I need to add 2. And I check, does that work with the others? 3 times 2, when n is 2, 3 times 2 is 6. 6 plus 2 is 8. 3 times 3 is 9. Add 2 is 11, etc. The other way to get this plus 2, so I get the 3n from that plus 3. The other way to get that term is to say what would have been the previous term to these. So if I work backwards, taking away 3 each time, I get 2, so it's 3n plus 2. 2 different ways of finding that missing number. This one is going up in 5s each time. So that tells me that 5n is involved. 5 times 1 is 5. What do I do to that 5 to get to 9? I need to add 4. Does that work when n is 2? 5 times 2 is 10, plus 4 is 14. 5 times 3 is 15, plus 4 is 19. It all seems to be working. 5 times 5 is 25, plus 4 is 29. That all works, and if I check what was the previous term, subtract 5, I get 4 down there, so 5n plus 4 is correct. In this one, it's going up by 6 each time. Tells me that 6n is involved. 6 times 1 is 6. How do I get from that 6 to 3? I need to subtract 3. Does it work for 2? 6 times 2 is 12. Take away 3 is 9. Yes. 6 times 3 is 18. Take away 3 is 15. Also, if I went back 6 from 3, I would get down to minus 3. This one is going up in 2s. So I know that I've got 2n involved. 2 times 1 is 2. Nothing needs to happen, I've already got 2. 2 times 2 is 4. This is just the 2 times table, and that represents the 2 times table. 2 times 1, 2 times 2, 2 times 3, etc. And if I look at the previous term, it would be 0, so I've got plus 0 on the end, which I don't need to write. That sequence is just 2n. Find the first 3 terms of the sequence with the nth term 3n minus 2. First 3 terms, I just say that's when n equals 1, then n equals 2, then n equals 3. So I've got 3 times 1, that's 3, minus 2 is 1. When n is 2, 3 times 2 is 6, take away 2 is 4. 3 times 3 is 9, take away 2 is 7. And just check that that works with that sequence as well. It's going up in 3s, which is related to the 3n, and the first one is as we've already put. And if I were to go back 1 term, I would have minus 2. So everything is matching up with what I know about that sequence. Find the first 3 terms of the sequence with nth term 2n plus 4. Again, when n is 1, when n is 2, when n is 3 will give me the first 3 terms. 2 times 1 is 2, plus 4 is 6. 2 times 2 is 4, plus 4 is 8. 2 times 3 is 6, plus 4 is 10. Is this going up in 2s like it should be? Yes, it is. And would the previous term be 4 if there was one? Yes, it would. So everything is matching up for those first 3 terms. We'll go on to substitution. This is replacing letters with numbers. When x is 4 and y is 2, that gives me 3 times by 4, because 3x means 3 times by. 5y means 5 times by whatever y is. That gives me 12 plus 10, which is 22. ABC means A times by B times by C, so 2 times by 3 times by 5. 2 3s are 6, times by 5 is 30. 7f's take away 2t when s is 4 and t equals minus 3, so we need to be really careful with the minus signs here. I've got 7 times 4 minus 2 times minus 3. Do the multiplications first, because of BIDMAS, because of the order of operations. 7 times 4 is 28, minus 2 times minus 3, which is minus 6. Two minus signs together, or taking away a negative, is the same as adding. So that equals 28 plus 6, which gives us the answer of 34. Find 4 lots of 2n minus 3 when n equals 5. 4 times by, do the bracket first, 2 times 5 minus 3. That is 4 times, that's 10 minus 3 in the bracket. You might want to skip that stage, that's just 4 times by 7, which is 28. On to solving slightly more difficult equations involving brackets here and sometimes an unknown on both sides. So first thing I would do here, expand the brackets. 6x minus 12 equals 24. Add a 12 to both sides, doing that inverse operations to get the x's on their own. 6x equals 36, 24 plus 12. Divide by 6 to get the x on its own. X equals 36 divided by 6, which is 6. Another method to do that would have been to start by dividing by 6, seeing as we can. If I divided both sides by 6, that would just leave me with x minus 2 equals 4. Add 2 to both sides gives you x equals 6 again. So we could use that method instead. I'm going to follow through with the expanding brackets because most people tend to do that. 5 times 4y is 20y plus 5 times 2, which is 10, equals 70. Again, we want to get the bits involving the unknown on their own. So 20y on its own, I need to get rid of the 10 from both sides. 20y equals 60. Now divide both sides by 20 to get y on its own. Y equals 60 divided by 20, which is 3. Again, you could work backwards to check that one. If y is 3, 4 times 3 is 12, plus another 2 is 14, and 5 times 14 is 70, so that's correct. This one, question 3, we've got an unknown on both sides. So what I want to do here, I've got x's on this side and on this side. I need to look for the smallest amount of x's, which is 2x, and take them away from both sides. That's my first step. So I'm going to take the smallest amount of x's away from both sides. That leaves me with no x's at all on this side, just the 4 left over. 5x take away 2x is 3x minus 8. Now I need to get this 3x on its own, so inverse operation to minus 8, adding 8 to both sides. 4 plus 8 is 12, equals 3x. The x is on the other side to normal, but it works in exactly the same way. I'm trying to get it on its own, so I now divide by 3. 12 divided by 3 is 4, equals x on its own, so my answer is x equals 4. Same process here, I've got x's on both sides, so I look for the smallest number of x's, which is 2x. So I'm going to take that 2x away. That's so that I end up with a positive number of x's on this side. 4x take away 2x is 2x minus 3, and all that's left on this side is the 2, now that I've taken away the 2x. I want to get the 2x's on their own, so I add 3 to both sides. 2x equals 5, 2 plus 3 is 5. Now divide by 2 to get the x on its own. X equals 2.5. 5 divided by 2, 2.5. Or 5 over 2 is a good answer. That's fine too. Or 2.5. Any of those are the correct answer. Question 5. I need to expand the brackets in order to start. So that gives me 3x plus 18 equals 4x plus 20. Now I need to look for the smallest amount of x's. That's 3x's. So I take away 3x from both sides, leaving me with 18 on this side. 4x take away 3x is x, and I've still got the plus 20 to deal with. Get rid of that plus 20 by minusing it from both sides, inverse operation. 18 take away 20 leaves me with minus 2, and on this side I'm just left with the x, and therefore the answer is x equals minus 2. Okay, last two algebra skills. Factorising, that means put back in brackets. So factorise means put in brackets by finding the highest common factor of every term. Highest thing that goes into both 3x and 33 is 3, so I find that common factor and then I work out what would happen. What do I need to multiply by to end up with 3x? And the answer is just x. What do I need to multiply by to end up with 33? And the answer is 11. So it's basically take each term and divide it by that factor that we've found. In this case, the highest common factor, the highest thing that goes into 5y and 25 is 5. Divide 5y by 5 and I get y. Divide 25 by 5 and I get 5. So I've got 5y plus 5 in there. With these, always just check in your head that it would expand to the original one. It's just the inverse process of expanding brackets. This one, does 4 go into 18? The answer is no, not as a whole number. So the highest number that goes into both 4 and 18 is 2. What do I multiply 2 by to end up with 4a? The answer is 2a. What do I multiply by 2 to get to 18? Is a 9, and I've got that minus sign followed through in the middle. The highest common factor of x squared and 4x is just x. That's the only thing that goes into both of them. In order to get x squared, I need to multiply that x by another x. In order to get 4x, I need to multiply that x by 4. So that goes there. That's the answer to all of those factorised questions. And finally, substitution with some more difficult numbers and some powers. Find 3x minus 4y when x is 5 and y is minus 3. So I've got 3 times 5 minus 4 times minus 3. Do the multiplications first. That is 15 minus 12, which is the same as 15 plus 12. Minusing a minus is a plus, so that leaves us with 27. A squared plus 3b, when a is 4 and b is minus 2. So I need to do the squaring first. 4 squared plus 3 times minus 2. 4 squared is 16, plus 3 times minus 2 is minus 6. That is the same as, if I've got two different signs, I just know I need to take away. So that's the 16 minus 6, which is 10. 4x squared when x is 3. I need to remember that indices have to happen before multiplying. So I don't do 4 times 3 is 12 and square it. Instead, I do 3 squared, which is 9, and then do the multiplication. 4 times 9 is 36. And this is slightly more complicated because of the minus sign. I've got x times by y squared. Remember, that is a hidden multiplier inside there. And I'm going to square y first. So 2 times by minus 3 squared. And I need to remember that when I square minus 3, that is minus 3 times by minus 3, that is a positive answer. Negative times a negative is a positive. So squaring the negative number gives me a positive number, and then I need to multiply that by 2, which gives me 18. Find 5x squared plus 2y squared when x is 2 and y is 3. Again, I need to do the squaring first. 5 times 2 squared plus 2 times 3 squared. That is 5 times 4 plus 2 times 9. That is 20 plus 18, so the answer is 38, using the correct order of operations all the way through. And that's it for the algebra revision map.